So we're going to take our lesson on basically applying radian measure to things we already know, a little bit further here. You might recall that complements and supplements have to do with relations between two angles. Two angles are supplements if their sum is 90 degrees, or, as we just discovered, pi over 2 radians. And two angles are supplements if their sum is 180 degrees, or pi radians. So what we're going to do is practice these ideas using radians. So the complement of an angle that's pi over 5 radians would be, well, let's see. So the complement would be pi over 2 minus pi over 5. If two things add up to pi over 2, and I know one of the things that add up, I know I subtract from pi over 2 to get the other. And one thing you could do, if you don't like working with fractions by hand, but remember that using pi in a calculator can be messy, I'm just going to take 1/2 minus 1/5. And that does give me 0.3. And if I change that to a fraction, I get 3/10, which means that is going to be 3 pi over 10. For the supplement, I'm going to take pi minus pi over 5. And I know that 1 minus a fifth is 4/5, so that's going to be 4 pi over 5. So those are the complements and supplements. Okay, so arc length, just coming back around to it. I know that's where we kind of started this whole thing, but just to cover it formally, the arc length S is equal to R times theta. So just to show that we have a circle, and let's say that it has a radius of R, and let's say it has a central angle of theta, then that means that this part of the arc right here has length S. Okay, I'm going to try to color that in so you can see it. And the important thing to remember is that the angle has to be in radians. That is the direct link between radius and length. So we have to make sure that if we're given an angle in degrees to convert it to radians before finding the length. Otherwise, it's going to look like a really weird answer. So let's look at this question. So what angle in radians is required for a 10-inch arc to be made if the radius is 4? Now we could draw a picture, but we know that this follows S equals R theta. We know that our arc is 10 inches long and our radius is 4. So that tells you that the angle has to be 10 over 4, which is 2.5. And again, that is 2.5. RAD is the official abbreviation for radians. So there we have it. And one more time, find the length of an arc whose central angle is 150, whose radius is 6 feet. So I have a circle, and I'm just going to, whoop, that did not come through as a circle too well. I can try that again. Circle. Okay, it understood that one for whatever reason. Okay, so the radius is 6, and we're talking about a 150-degree angle, which looks something like that. Now remember, we need 150 to look like radians first. So 150 times pi over 180 is the conversion factor, and that gives me 5 pi over 6. So that means that the length of my arc is R theta, which is 6 times 5 pi over 6, which is 5 pi, and it's going to have the same units as the radius. That's 5 pi feet. Okay, so there's some geometrical significances with radians as well. Later on, we'll also look at the area of a circular sector, kind of an interesting formula that comes out from that. But before we get to that, that's what I consider extra. We will look in the next video at linear velocity and angular velocity. So make sure to stay tuned for that.